Natural language processing, NLP, is a subfield of artificial intelligence, AI, focused on enabling computers to understand, interpret, and generate human language. The primary goal of NLP is to bridge the gap between human communication and machine understanding, allowing machines to process and respond to natural language input in a meaningful way. NLP combines computational linguistics, machine learning, and deep learning techniques to analyze and process textual or spoken data. Applications of NLP are vast, ranging from machine translation and text summarization to sentiment analysis and chatbots. Key concepts in NLP. Text preprocessing. Before applying NLP techniques, raw text often requires cleaning and transformation. Tokenization, the process of breaking text into smaller units, tokens, such as words, subwords, or sentences. Stop word removal, stop words, for example, and the, in, are often removed because they do not contribute significantly to the meaning of the text. Stemming, reducing words to their base form, for example, running, run. Lemmatization, similar to stemming but more advanced, lemmatization converts words to their dictionary form, for example, better, good. Lowercasing, converting all text to lowercase to avoid distinguishing between word in different cases, for example, apple versus apple. Removing special characters, removing non-alphanumeric characters or formatting like punctuation, which might not be relevant to the task. Part-of-speech tagging, POS assigning grammatical categories, such as noun, verb, adjective, to words in a sentence. Text representation, bag of words, BAW represents a text as a collection of words, disregarding grammar and word order but keeping track of word frequency. TF-IDF, term frequency inverse document frequency, a statistical method used to evaluate how important a word is to a document in a corpus. It helps in reducing the weight of common words and emphasizes the more unique ones. Word embeddings, representing words as dense vectors in a continuous vector space. Word embeddings capture semantic meanings, allowing the model to understand word relationships. Common embeddings include Word2Vec, a shallow neural network that learns word representations based on context. GloVe, global vectors for word representation, another word embedding technique based on word co-occurrence statistics. FastText, an extension of Word2Vec that takes subword information into account. BERT, bidirectional encoder representations from transformers, a contextual word embedding model that processes the text in both directions, left to right and right to left, offering richer and more accurate embeddings for each word. Types of NLP tasks. Text classification, assigning predefined categories to a given text. Common tasks include sentiment analysis, determining whether the sentiment of a text is positive, negative, or neutral. Spam detection, identifying whether an email is spam or not. Topic classification, assigning a topic or category to a document, for example, politics, sports, health. Named entity recognition, NR, identifying and classifying entities in a text, such as names of people, organizations, dates, locations, and more. Apple Incorporated announced the release of the iPhone 14 on September 1, 2025. Here, Apple Incorporated is an organization, iPhone 14 is a product, and September 1, 2025 is a date. Part-of-speech tagging, POS assigning grammatical tags to words, such as noun, verb, adjective, etc. This helps in understanding the syntactic structure of sentences. Example: the quick brown fox jumps over the lazy dog. The determiner, quick, adjective, brown, adjective, fox. Noun, jumps, verb, over, preposition, the determiner, lazy, adjective, dog, noun. Machine translation, translating text from one language to another. Popular systems include Google Translate and DeepL. Modern systems use neural machine translation, NMT, based on deep learning models, particularly sequence-to-sequence models. Question answering, QA developing systems that can answer questions posed in natural language. This can involve extractive QA, the answer is directly extracted from a given document. Abstractive QA, the system generates an answer based on its understanding of the text, rather than extracting from it verbatim. Text summarization, generating a concise summary of a longer text, which can be extractive summarization, selecting key sentences or phrases directly from the text. Abstractive summarization, generating new sentences that convey the main points of the text. Speech recognition, converting spoken language into text. This is used in applications like virtual assistants, for example, Siri, Alexa, and transcription services. Text generation, creating coherent and contextually relevant text based on a given input. This is used in applications like chatbots, story generation, and code generation. GPT, generative pre-trained transformer, models, like GPT-3, are state-of-the-art for text generation tasks. Advanced NLP models. Transformers. Transformers are a deep learning architecture introduced by the paper Attention is All You Need, 2017, and they have revolutionized NLP tasks. They rely on self-attention mechanisms to process all words in a sequence simultaneously, rather than sequentially, as RNNs do. This enables parallel processing and captures long-range dependencies more effectively. Popular transformer-based models include BERT, focuses on bidirectional context for word embeddings and is fine-tuned for specific NLP tasks like question answering and classification. GPT, a unidirectional transformer model, pre-trained on large datasets and fine-tuned for specific tasks such as text generation and language modeling. T5, text-to-text transfer transformer treats all NLP tasks as a text-to-text problem, making it highly versatile. XLNet, builds on BERT by using a permutation-based approach to capture dependencies across sequences. Recurrent neural networks, RNNs. RNNs are used for processing sequential data, such as text. They have internal states, memory, that capture information from previous time steps, making them suitable for tasks like speech recognition and machine translation. LSTM, long short-term memory, and GRU, gated recurrent unit, are more advanced types of RNNs that address issues like vanishing gradients and long-range dependencies. Applications of NLP. Chatbots and virtual assistants. Chatbots, for example, GPT-powered chatbots, use NLP to interact with users in natural language, answering questions, providing assistance, or even engaging in conversations. Virtual assistants like Google Assistant, Siri, and Alexa rely on NLP for speech recognition, understanding commands, and responding to queries. Sentiment analysis in social media. NLP models are widely used to analyze public sentiment about brands, products, or events from social media posts, reviews, and news articles. Automated content generation, NLP models, especially those based on GPT and other transformers, can generate human-like text, which can be applied to content creation, marketing, and journalism. Speech-to-text and text-to-speech, NLP models are integral to converting speech to text for transcription. Purposes or converting text to speech for applications like audiobook reading. Healthcare, NLP helps in analyzing unstructured data from medical records, extracting useful information, and supporting decision-making for diagnosis and treatment. Legal and compliance, NLP is used to analyze legal documents, automate contract review, and ensure compliance with regulations. Challenges in NLP. Ambiguity in context. Words or phrases can have multiple meanings based on context. For example, bat can mean a flying mammal or a piece of sports equipment. Disambiguating words based on context is a key challenge in NLP. Language variability. NLP models must handle variations in grammar, dialects, idioms, slang, and the evolution of language over time. Data scarcity and bias. NLP models require large amounts of annotated data for training, which may not be available for all languages or domains. Additionally, biases in the data can lead to biased model predictions. Computational complexity. Advanced NLP models like transformers require significant computational resources for training and inference, especially in languages with vast corpora. Summary. NLP is a rapidly evolving field that allows computers to understand and interact with human language in a natural, meaningful way. From text classification and machine translation to chatbots and sentiment analysis, NLP has many practical applications across various industries. With advancements in deep learning, particularly transformer models, NLP continues to improve in accuracy and sophistication, making it one of the most exciting areas of AI research.